In this video, we're going to be talking about electronegativity and the polarity of molecules. So electronegativity is basically just an atom's ability to be able to gain electrons and form bonds. So if we look at a periodic table, we're going to see that as we go up in groups and as we go along periods, we're going to see electronegativity increase. So we can think of it kind of like a gradient. So francium is going to be the least electronegative atom, and then it goes up like this, and so helium is going to be the most electronegative. So it's basically just like that. And what you need to know is that when we get to a drawing, we're going to see that the less electronegative atom, we're going to say that the less electronegative atom in the bond, we're going to give the symbol delta plus, the Greek letter delta plus, and then the more electronegative atom is going to have the symbol delta minus. So now that we know what electronegativity is, we can start to talk about the polarity of molecules and atoms. So we can think of polarity as a difference in charge from one side of the atom to the other. So imagine we have a water molecule. So we've got our oxygen and we've got two hydrogens. We're going to know that there's going to be a bond here and a bond here, and each of the hydrogen's atoms is going to be used up. And then oxygen, if we look at a periodic table, we're going to see that it's in group 6, so it's going to have 6 electrons in its outer shell. So 1, 2, 3, 4, 5, 6, and then obviously the 2 from the hydrogen make it 8. But we can see that this side of the atom is going to have more electrons than this side. So we can then draw our symbols. So the less electronegative atom or side of the atom is going to have delta plus. So this side is going to be delta plus, and then this side is going to be delta minus because it's got more electrons. So you can kind of see how that makes sense. Like if you have magnets, say this is the positive side and this is the negative side, when they come together, it's basically the same thing. It's polar. So the North Pole, South Pole, they come together. And when opposite poles, so say there was a water molecule and another one, but both of the oxygens were coming together, it's going to do this and push it away. Now that we have the basic idea of electronegativity and polarity, we can start to talk about more complex structures. So say, for example, we have the compound CCl4, and we was to draw this. If you don't know how to draw the 3D structures of molecules, then go and watch my other video because I explain how to do it there. But we're going to see that we're going to have a carbon in the middle, we're going to have a chlorine there, a chlorine there, a chlorine coming out, and a chlorine going behind. So if we look at a periodic table again, we're going to see that chlorine is over here and carbon is here. So we can see that chlorine is going to be more electronegative than carbon is going to be. So if we get our pens, remember that the less electronegative atom in the bond is going to be delta plus. So the less electronegative, which is carbon, is going to be delta plus. And then that means that the less electronegative atoms are going to be delta minus. Now, if we're to say if this is going to be polar or non-polar, we have to kind of think about it. So we can think of this as somewhat like a 2D structure. It isn't actually, it's 3D, but just for analogy, imagine this is our atom, our molecule. We're going to have our carbon in the middle, and we're going to have 4 chlorines around the side of it. So we're going to be able to see that there's the carbon in the middle and then 4 chlorines around it. And even though this is a pyramid shape, what is going to be its polarity? Or is it going to be polar or non-polar? So let's see. If we get a magnet, which this is another molecule, if we push them together, you see that it's going to push it away. Even though there's the positive in the middle, the outside of it is going to be negative, so it's going to be pushed away. So therefore, we can conclude that this is going to be non-polar. Because if it was polar, we would have a difference in charge across the atom. But as we can see, no matter where we take the line of symmetry, it's going to be the same. So it's going to be non-polar, sorry. Now, if we was to look at a molecule like ammonia, for example, so NH3, if we was to draw this out, we would get this. So looking at the periodic table again, we're going to see that hydrogen is going to be over here and nitrogen is going to be over here. Therefore, the hydrogen is going to be the less electronegative. So we can say that this is going to be delta plus. And we can see that nitrogen is going to be our delta minus. So is this molecule going to be polar or non-polar? Well, we can see that if we take a line of symmetry here, we're going to see that this side is going to be negatively charged and this side is going to be positively charged. So we can just draw that like this. So therefore, like my magnet analogy, if we brought, imagine this was a nitrogen and these was hydrogens. If we bring it over here, it's going to attract. So this is going to be polar because it attracts. Another thing to note is that when two elements are bonded which are the same, it's going to be non-polar. Because look, imagine we have a carbon bond. So carbon is bonded. We're going to see carbon is here and carbon is also here. So they're going to have the same electronegativity. So that would mean that it's non-polar because one side of the molecule has not got a different charge from the other side. They're equal, which kind of looks like the bottom. However, if you have something like hydrogen bonded with chlorine, we can see if we look at hydrogen, that'll be there, chlorine will be there. Obviously, chlorine is more electronegative, so the more electronegative, we're going to draw delta minus. The less electronegative, we're going to put delta plus, and we can clearly see that this side has a different charge to this side. Therefore, this is going to be polar, this is going to be non-polar. And generally, what we can say is that all linear, trigonal, planar, tetrahedral, and octahedral shaped molecules are going to be non-polar. But there's exceptions. Like this one here, for example, technically this would be a tetrahedral shape, but it's going to be polar because this here is not an actual atom coming out. It's just a lone pair of electrons. So it makes it look like the shape of tetrahedral, but it's still going to be polar. So you have to think about it. And like I said in the last video, drawing the diagrams often help. So again, in the last video, if you're not sure how to draw the diagrams, draw the dot and cross diagrams first, and then that makes it a lot easier to draw the 3D structures. But for electronegativity and polarity, that's basically it. We don't really need to know too much more. You just have to practice stuff like that. And that's basically it.